Right, so this is going to explain the, computer programming A. This is about transformations, like you've seen in algebra class, geometry class, maybe algebra 2, definitely in pre-calculus. There's this idea of transformations. How do you move this function, in this case, function draws a shape, different places? How do you scale it? And we're going to go into the specifics of how it works in terms of your code. We go to our handy-dandy game lab. Looks like this, and I borrowed some code from the shape function. You saw that if we go to this see examples, this is called the documentation. They have some cool examples like this star. So what I did was I copy and pasted this and added it here, and then I get this gray star in the middle. Some of you are asking for help in your national flag assignment where stars are a really big theme. That, oh, Mr. Chen, I want to make it smaller. I don't want it in the middle, and I don't want it that big. How do I do that? And the first suggestion we have is like, oh, why don't you try cutting everything down by 2? So to show you that change, I'm going to copy and paste this, post it down here, and I'll show you the change. Here's the original star, and then I have, when I click run, I see 2 stars on top of one another. The second star, I'm going to try to change, divide by 2, right? So I'm going to divide each of these xy coordinate pairs by 2. And you may have noticed that the star shrinks, but it also does something else. It moved closer to that origin point in the upper left-hand corner. Okay, almost there, last coordinate, like that. So what do I mean? Like this. If you were to draw a little line connecting this, that's where the dilation comes in. You're like shrinking it and also moving it closer to the origin. This is half as big because every single coordinate got divided by 2. You can start putting in more complicated expressions into these numbers called arguments instead of calculating it out and tweaking it just by like going like 290, 291 and tweaking it like that. The purpose of this is that computers are really good at doing calculations. So you're making the computer do this division for you. And the part I want to highlight next is like this is kind of like a slope. This is kind of like the width of a parabola. This is kind of like scaling your triangles down for geometry. It's like changing the amplitude if you're in pre-calculus on like your sine curves or whatever it is. It changes like the area. Let's say we wanted to add 100 though. And I'm only going to add 100 to every other coordinate, which matches the x coordinate for each of these coordinate pairs. What do you think will happen when I click run after adding 100 to each of these x coordinates? Guess for a little bit. You may pause the video now if you want. And now I reveal the answer. So, what did you notice from the star? Shifted over to the right, right? It was originally here, and now it moved there. When adding that 100, notice that it got translated one-dimensionally in the x-axis. By adding 100, we're telling it to go over 100 pixels. Now imagine, let's test to see if you know, if I subtract 100 from the y-coordinate, what do you think will happen then? Think about it. 5, 4, 3, 2, 1. I finished typing in that 100. We'll have the code tell us minus 100 from each one. Maybe you thought it went down the screen, maybe over here. Maybe you think it went up the screen. If you thought up or down, you are on the right track, and then let's find out. Boop, it popped up here. And that's because the origin is defined in the upper left-hand corner. And remember, y increases going down positively this way. This is your height. This is like, notice in the y-coordinate right there in the show grid, this is 360. And then down here is like 400 or so. It starts at 0, increases this way. X-axis is just like math, but the y-axis is kind of funny. You would think it might have gone like negative y. That's where computer graphics is different than drawing out these shapes than your normal coordinate axes. Questions so far? None? Okay. So one student asked in the previous class, like, why bother to show all those work when you can just replace it with numbers? And they asked me after I stopped this video lecture, so I'll answer it now, because this is where it becomes really useful. You're going to see and I'll introduce this now, that you can store things in like a variable. Just like in math, for example, let's have this variable go here, variable x. And x is going to change in that 100, for example. Let's have it move like here. When subtracting x, I'll put, yes. Let's have this part go here, right? Anytime I see 100, it's going to be substituted in. It's going to take the place of that x change. And you're going to see that once I show my workout, once I spell out these expressions using the division and adding symbols, it becomes a little bit easier to manipulate it. What do I mean? For example, right? Notice no change, but suddenly if I change this to like 50, it's going to move half as far, and that's less typing for me. Let's say I copy and paste this line. I wanted a star in a later portion, but I wanted this x to change like scratch that. So now we can change it, let's say -50, reset, goes over there. I can change it now to like 200, and it'll move farther over there. We're translating across the x-axis, and you could do the same with the y-axis instead of having to retype it out. That's the purpose of having these mathematical expressions instead of tweaking all the numbers. Later on, this idea comes back again when we define our own functions to generalize how we think about moving these shapes. Questions? All right, computer programming A, I'm done. Go back to coding. I'll stop the video. Think.